continuing on with our discussion of difference of squares, now I'm going to ask myself the same thing. Can I make it simpler? Ooh, I can. And I noticed I don't have a perfect square minus a perfect square. So the only thing I can do to start is to make it simpler. Well, what is the greatest common factor here? 3 can come out of both, and 1b. So then I would distribute backwards. So I would get 3b times b squared. 3b times what gives me 9. Yes, we did simplify it. Did we simplify it to the final form? Is there something that can be done here? Well, I'm going to ask myself, because I have a binomial with subtraction, is this a perfect square minus a perfect square? It is. So I will just drop down the 3b. 3b, cannot lose it. I'm going to take the square root of the a term, take the square root of the c term. 1 will be addition, 1 will be subtraction. So when I'm done foiling it out, I will not have a b center term. Okay, so this looks a little different. Now, if I was going to ask you to solve, remember we have something set equal to 0. Every factor needs to be set equal to 0. Oh, this is peculiar. Something we have not had yet. I would divide by 3, divide by 3. Okay, so b could equal 0. Subtract 3 from both sides. B could be -3. And add 3 to both sides. Now, I have 3 answers. We shouldn't be surprised by that. Remember, we talked about if the exponent tells me the number of solutions. These are your x-intercepts, also known as the roots. We will have solutions like this a little bit as we go, but much of our stuff we will work with will have x squared. You will get this more in Algebra 2. So what this really means is I'll switch colors, one x-intercept is here, 1 is back at -3, 1 is at +3. So you have the potential of the line looking something like this, with lots of other information needed to graph. Or again, maybe it looks like this. But you would end with 3 roots, 3 x-intercepts, because we started with a binomial to the 3rd degree. Okay, let's try another one that's very, very similar. First question, can we make it simpler? Oh, yes. When I look at the first term and the second term, I notice there is a greatest common factor. My greatest common factor would be 4x. So I will distribute backwards. I'm going to take out 4x, leaving me with x squared minus 4 equals 0. Now I realize we did do some factoring, but we did not factor it all the way down. And you need to factor it all the way down. So I will double check, because I notice I have a binomial here. Is that a perfect square minus a perfect square? It is. Drop down our greatest common factor. Take the square root of the a term minus the square root of the c term. And we would have opposites so that I don't have a b term in the center. This is still equal to 0. I am going to get 3 answers because the degree is 3. I will set each one equal to 0. So I have x can be 0, x will be 2, x will be negative 2. Those are my roots / x-intercepts. And I'm not surprised by 3 of them again because of that exponent. If we were to sketch a graph, which we aren't going to do for a bit, one x-intercept would be here, positive 2, negative 2, and we would either have, whoops, I missed the point, but that's all right, something that looks like that, or we might have something that looks like that. And there's lots of things we would learn to figure the height and the minimums, the width, etc. Okay, I need to turn the page. I'm going to do one more with you, and then I'm going to ask you to try a couple by yourself. Okay, can we make it simpler? I hope that every time you approach a problem, you are asking yourself that question. No, I cannot make this one simpler. But I notice I have a binomial. Then I will ask, is that a perfect square? Yes. Is that a perfect square? Yes. So I will take the square root of the a term. I'll take the square root of the c term. And one will be plus. I will repeat with a subtraction. So 5x plus 12 times 5x minus 12. I know I simplified as far as I can go because there isn't a greatest common factor. I would like you to try the next two, just this one and the one below it on your own. Ask yourself, can I make it simpler? It's a binomial. Is it a perfect square minus a perfect square? Please pause the video. Make sure you simplify it as far as you can. I do realize as we go through this, I didn't ask you to solve them, but I thought I would throw that on there just for you to look at another example or two of what we would do. My final answer is if I asked you just to factor these binomials would be right here. I hope you did not forget about the greatest common factor we pulled out. Make sure when you're done, if you have an exponent or degree of 3, you end with 3 factors or 3 terms being multiplied. Same thing here. Did you notice the only thing I could take out was an x? If you do not factor out the x, you do not have a perfect square here. X cubed is not a perfect square. Take a moment, compare your answers to mine, give the video a pause if you need to review, or go ahead and rewind. It doesn't hurt to watch it again.